Good morning, students. Welcome back. In previous lecture, we have studied about the binomial theorem, chapter 8. In that lecture, we have studied about how to apply the binomial theorem, what are the binomial coefficients, and what is the Pascal rule to find out the coefficients of the binomial. Now, in this lecture, we will study about the few questions of exercise 8.1. Now, first of all, we'll solve the question number 12. Here, question is find x plus 1 whole power 6 plus x minus 1 whole power 6. Hence, find or evaluate root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. As it is written, hence word. You must be careful about this word. It means solve the previous one and use it. Find out the next one. What's the meaning of this? Use this previous result to find out the next result. It's clear now? It means first of all, I have to expand this expansion x plus 1 whole power 6 plus 1 plus x minus 1 whole power 6. And then by using the result of this, I have to find out the result of root 2 plus 1 whole power x plus root 2 minus 1 whole power x. Now here, first of all, two expansions are written here. We will solve first expansion one by one. We will solve it. First expansion is x plus 1 whole power 6. First of all, I have to solve this one. Then second expansion, x minus 1 whole power 6, and add them. For the first expansion, x plus 1 whole power 6, I think you have remembered the binomial theorem. If you don't remember, then I have to write down. Let's write what is the binomial theorem. As it is told you in previous lecture, even then I am writing here now. It is what? A plus b whole power n, that is equal to nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1. And third term nc2 a to the power n minus 2 b to the power 2. And last term will be ncn a to the power 0 and b to the power n. Now apply this expansion on x plus 1 whole power 6. Here a is equal to x and b is equal to 1. Now what it becomes? 6c0 x to the power 6, because the value of n is 6. Okay, 6c1 x to the power 5, second term, 6c2 x to the power 4, and up to last term 6c6. You can find by putting the value of a, b, and n in the expansion a plus b whole power n. Number of terms you will get, index is 6. The number of terms will be 6 plus 1, that is 7. You can count 1, 2, 3, 4, 5, 6, 7. Number of terms in the expansion x plus 1 whole power 6 are 7. So you can solve it and expand it by using the binomial theorem. Now expand x minus 1 whole power 6. Now at the place of 1, now you have to write down minus 1. Let's write like this. Suppose you are writing here x minus 1 whole power 6 means what? 6c0 x to the power 6 and minus 1 to the power 0 plus 6c1 x to the power 5 and minus 1 to the power 1. That's why you will get here minus sign. Next one, plus 6c2 x to the power 4 minus 1 to the power 2 becomes positive sign. That's why here is positive. So plus 6c3 x to the power 3 minus 1 to the power 3. Again you are getting what? Minus 1 to the power odd. That's why here is minus sign. If you get positive, it means power is even. And if you are getting negative sign, it means power is odd. And you will get the expansion of x minus 1 whole power 6 up to 6c6. I think you remember it, the formula of NCR, because now in next step you have to solve the combination. Factorial n upon factorial r factorial n minus r. You will apply this formula of combination. In previous chapter we have studied it in permutations and combination. Okay, now come to here. Yes, x plus 1 whole power 6 plus x minus 1 whole power 6, add them. As you add them, plus and minus terms both are cancelled to each other, and first term of the expansion added, you will get twice of 6c0x to the power 6, and 2 is taking outside. Those terms which you are adding, you will get common 2 from those terms. You are getting 2 common, and these 4 terms you will get. Other terms are cancelled out, as 6c1 and x to the power 5 cancelled with this term. It is cancelled by this, and these are cancelled by this. So after applying the formula of combination NCR, simplify the coefficients of x to the power 6, x to the power 4, x to the power 2, and you will get what? First coefficient is 1, second is 15, third is 15, and last is 1. As you know, first and last both coefficients are same. Second and second last coefficients will be same. As third and third last coefficient will be same, fourth last will be same, and so on. This is a procedure which we have discussed in the Pascal's triangle format. Now, next part of this question is evaluate root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. It means what? In the expansion which you have solved here, you have to put x is equal to root 2, and you will get the value of this required evaluation part. You must remember it here. Hence word is written. Hence means what? Solve the previous one and find the next one. By using the previous one, you will use the expansion this and find out the evaluation of root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. Sometimes students understand that you have to solve only this part. They started to do question from this root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6 and solve the question. But that is a wrong one. First, you have to solve the general expansion. Then, by using this general expansion, you have to find out the next, whatever it is given to you. Here it is given x is equal to root 2. After putting in general expansion, x is equal to root 2, you will get the solution. Putting x is equal to root 2 in the previous expansion solution. This is a solution of the expansion. Now x is root 2. Put here root 2 whole power 6 plus 15, root 2 whole power 4, root 15 into root 2 whole power 2 plus 1, and simplify it. You will get, after simplification, that is 198. If you solve this equation by using expansion, and you will get answer the same, but requirement of question is what? You have to simplify the previous expansion. This you have to solve first. Hence means what? Solve the previous one and use this previous one, then find out the second part of the question. Okay. Here in the second question, the question number 13, show that 9 to the power n plus 1 minus 8n minus 9 is divisible by 64, where n is a positive integer. As we know the binomial expansion, in that binomial expansion, we can replace first quantity by 1 and second quantity by x. And now expand this expansion, you will get n plus 1 c0, n plus 1 c1x plus n plus 1 c2x square, and so on. Number of terms you will get, n plus 1 is the index, so number of terms will be n plus 1 plus 1. n plus 2 terms will be there. You are starting from 0, it means you will go up to the n plus 1. Last term will be n plus 1 c n plus 1 x to the power n plus 1. Now requirement of the question is what? When this whole statement is divided by 64, it is like this. This is I think same as last example of the exercise 8.1. Now let's do what is the meaning of this. Explain it again. Meaning of this is when you divide 9 to the power n plus 1 minus 8n minus 9 by 64, it means you are getting remainder is equal to 0 and quotient is here 1. Okay, so what? By using the checking rule, you will get what? 9 to the power n plus 1 minus 8n minus then will be equal to 64 times of q, because remainder is 0. That's why plus 0. There is no need to write down. Only 64 QR is the requirement of the question. Okay. Now by using the binomial theorem, we will go up to the this solution. Okay. Okay. Now in the expansion, requirement is 9 to the power n plus 1. If you put x is equal to 8, then you will get here 9. So what? Put x is equal to 8 in the solution, expansion solution. You will get what? N plus 1 C0, n plus 1 C1, 8 to the power 1, and n plus 1 C2, 8 to the power 2, and so on at the last term, up to the last term. Now solution becomes what? 9 to the power n plus 1, n C0 is 1, same as n plus 1 C0 is 1. N C1 is n, so n plus 1 C1 will be n plus 1, and other terms are as it is. Now simplify it, it becomes 8n plus 8, and 8 it added in 1, 9. It means 8n plus 9 plus n plus 1 C2, 8 to the power 2, and so on. Now shift the right hand statement to the left hand part. 9 to the power n plus 1 in left side. Take the 8n to the left hand side and 9 to the left hand side. What are the left terms? From third term to last term are the terms which are in now right hand side. Take common 8 square from the terms third term to last term. What you are getting? N plus 1 C2 plus n plus 1 C3, 8. 8 cube becomes 8 when you take common 8 square from the 8 cube. So what? Up to last 8 to the power n plus 1 minus 2. N plus 1 minus 2, because you are taking 2 common, power 2 common, then it will what? It is what? I can write here like this. When you are taking common 8 to the power n plus 1 minus 2, what it becomes? 8 to the power n minus 1. Now what is this part? This whole part is taking as cube. This is cube. So this becomes 64 cube. This is the requirement of the question. When you divide the whole statement by 64, you are getting remainder 0. This is the question. Solve it. Now come to the next question. Yes. Question number 14. Prove that summation of r is equal to 0 to n. Yani number of terms are added from 0 to n. NCR r 3 to the power r can be written as 4 to the power n. Now as you know, the expansion 1 plus x whole power n can be written as nc0 plus nc1x plus nc2x square plus up to ncn x to the power n. If you want to write down this expansion in the summation form, then you can write it like this. Summation of statement NCR x to the power r up r is equal to 0 to n. If you put here x is equal to 3, you will get the same expansion. X is equal to 3 means what? In both sides. You are getting here 1 plus 3 whole power n, and this becomes NC0 3 to the power r. What are you getting? Same as the question, you will get the statement 4 to the power n is equal to summation of NCR 3 to the power from r is equal to 0 to n. This is the requirement of the question. Okay. Now this question can be expanded like this. Let's discuss one more way of doing this question. Yes, I'm giving to you hint. Do that question accordingly. Also, this is a second way. Suppose you are taking right hand side. If you are taking right hand side, that is 4 to the power n, you can write it as 1 plus 3 whole power n. Now expand it. Expand by using binomial expansion, binomial theorem. You will get the expansion that will be 1 plus 3 whole power n will be equal to NC0 1 to the power n 3 to the power 0, NC1 1 to the power n minus 1 3 to the power 1, and this is up to NCN 1 to the power 0 and 3 to the power n. When you put r is equal to 0 in this expansion, you will get first term. When you put r is equal to 1, you will get second term. When you put r is equal to 2, you will get third term. And when you put r is equal to n, you will get the last term, this one. So what this whole statement can be written as like this. It means what? 1 plus 3 whole power n can be written as summation of r is equal to 0 to n on it NCR 3 to the power r. So this is the solution. You can do question like this also. Okay. The complete exercise 8.1. Thank you. Have a nice day. Have a knowledgeable day.